Alright, let's talk about the so-called Coriolis force. Many people claim the Coriolis effect proves the Earth is a globe. And I think it's interesting how people usually refer to it as an effect rather than a force. I have no complaints about that, because it is a fictitious force, very much like gravity. But you don't see very many people saying the gravity effect. We'll come back and talk about the gravity effect in another lesson. But before I get to that, I want to talk about the Coriolis effect and the Coriolis force, and then talk about how it is a fictitious force. And before I do that, I want to address the globe Earth claim and tell you what is wrong with it. Science ABC describes this claim in further detail.
Interestingly, cyclones in the northern hemisphere of our planet spin in the counterclockwise direction, while those that occur in the southern hemisphere spin clockwise. In fact, this is true for all storms.
We'll stop right there. Here's our first problem. That is utterly false.
Tornadoes usually rotate counterclockwise, but what happens when one is spotted turning the opposite direction?
Inside Science.
A tornado is a violently rotating column of air that extends from a thunderstorm, and that's the general definition of it.
A tornado in the northern hemisphere usually spins counterclockwise, but on rare occasions it can twist clockwise and is called an anticyclonic tornado.
Well, it all started with actually video. We got a video on our TV station from a lady that lives in the neighborhood where it went through. And actually, that thing looks like it's going clockwise. And I kept looking at it, and so then finally when we had a chance to really sit down and look at it, when we're not on the air, you can see it was going clockwise.
You can also see the anticyclone here on the radar. Red indicates winds moving away from the radar, and green shows winds moving towards the radar, creating a circle.
That's how you find a tornado, red next to the green. Well, you look at the red next to the green, it was flipped opposite to a clockwise, sure enough.
Inside Science. If you enjoyed this edition, follow us on the web and social media.
Alright, so there's the first hole in their claim. Now let's let them continue.
This happens due to the Coriolis effect, a physical phenomenon named after the French mathematician Gaspard Gustave de Coriolis.
Wait, hold on again real quick. Let me explain this. Wikipedia illustrates the Coriolis effect on a turntable, merry-go-round, or carousel. If you were to sit on a spinning merry-go-round and have someone in the center toss a ball at you, that ball's trajectory would appear to curve. The apparent force acting on that ball, causing it to curve in the air, is called Coriolis force. And just like gravity, we can describe it, we can say what it does to other things, we can measure it, and we can predict things with it. However, just like gravity, the Coriolis force is an illusion and is completely imaginary. This is why both gravity and the Coriolis force are referred to as pseudo-forces, or fictitious forces in science. Concerning the Coriolis force, the truth is revealed when we step off of the merry-go-round and we see the ball move in a straight line. Alright, now I'll let them continue.
Standing at Earth's North Pole, if you were to shoot an arrow at a target in the southern direction, towards the equator, the arrow would land west of the target, as the Earth rotates from west to east. However, if you shoot an arrow from the equator at a target towards the North Pole, then the arrow would land east of the target. Similarly, in the southern hemisphere, the arrow shot from the South Pole towards the equator would land west of the target, whereas the arrow shot towards the South Pole would land east of the target.
But remember, if we step off the merry-go-round, we should see it move in a straight line.
The same thing happens when winds, storms, and cyclones in the northern and southern hemispheres travel from and towards the equator. In both hemispheres, winds traveling towards the equator are diverted towards the west, while winds traveling towards the poles will curve eastward. But due to the presence of low pressure zones, these winds follow a circular path. This is why cyclones and hurricanes in the northern hemisphere spin counterclockwise, whereas those in the southern hemisphere spin clockwise.
Again, that is false. Not only because of the existence of anticyclones, but also because if you were to step off the merry-go-round, you would see the storms moving straight. The Coriolis force is also called an inertial force. Inertia is the property of matter by which it retains its state of rest or velocity along a straight line, so long as it's not acted upon by an external force. And if the Earth were actually a spinning globe, in which direction would the winds be moving? They would be moving outward like this, just like any object on a spinning merry-go-round. Yet look at the direction they claim these storms are flying. North and south? If I were to hop on a merry-go-round and spin it around really fast, do you think it would launch me upward? Nope! So if this is not caused by a spinning globe Earth, what is causing this on a stationary flat Earth? Well, one of the vocabulary words that you should really familiarize yourself with, if you haven't already, is the term jet stream. We usually bring this up when talking about plane flights, but jet streams are just fast-moving air currents at high altitudes. These air currents can reach up to 250 miles an hour, and when those air currents meet resistance, they curl out and away from the air current, and the direction of the curl depends on which side of the current it is on. So if it's on the right side of the current, that curl will turn right. And if it's on the left side of that curl will turn left. Now, Jeranism and the Globebusters have a really cool website called bobwinds.com. It works in conjunction with the US National Weather Service, and it shows the wind currents throughout the world. All of these big red, pink, and white areas are the major jet streams, and if you ever wonder how planes are able to travel so fast in the southern hemisphere, that's how they do it. Now, I've gone and zoomed in here for you so you can have a closer look. And as you look right off the coast of Alaska here, you can see this jet stream. Please notice how if you're moving with the jet stream, the wind on the right is turning clockwise, and the wind on the left is turning counterclockwise. It really isn't that rare of a thing. You can even see the same thing on a globe. This is earth.nullschool.net, a completely different website, also getting their info from the US National Weather Service. So here I'm going to go and adjust the height of the winds we are looking at. When it comes to air currents, as odd as it is, they determine height based on pressure with a system called HPA. 1000 HPA is about sea level, and the jet streams at 250 HPA are the ones that have a lot to do with their major weather patterns. And right off the bat, take a look at this clockwise wind rotation. And oh look, there's another one. And both of them are north of the equator. They are not that rare of a thing. So, storms do not curl because the Earth is a spinning ball. And the direction of a storm's swirl is just dependent upon which side of the jet stream it is on. Nothing more. Thank you for watching.